we have scenario like this. One switch, PC number 1, PC number 2. These are connected like this. Fine. Let's suppose this is fast Ethernet 0 by 1 and this is fast Ethernet 0 by 2. Clear? Understand? Now,
Yes.
we know switch is an intelligent device, right? Why switch is an intelligent device? Because switch learn the MAC address in its CAM table, right? And switch will take every forwarding decision according to the CAM table. That's the reason switch is an intelligent device. Fine. In recent interview, one interviewer asked very simple question: why switch is a layer 2 device and why router is a layer 3 device? What is your answer? Switch is a layer 2 device because it will take any forwarding decision on the basis of layer 2 address.
Right.
Fine. And router is a layer 3 device because router will take any forwarding decision on the basis of layer 3 address, that is the IP address. Clear? Understand? Let's suppose on PC number 1, we have IP address 10.1 and we know every PC has a unique MAC address. Let's suppose MAC address is 0A. Let's suppose IP address is 10.2 and MAC address is 0B. Fine, clear? Now, switch maintain one table. What is the name of that table, guys? CAM table. So this is the CAM table of switch. Now, let's suppose PC number 1 wants to ping PC number 2. So when you write the ping command on PC number 1, you know na ping is ping. What is ping? Ping is a utility. Ping, what is ping? Ping is a just utility and ping use which protocol? ICMP protocol. Fine. So when you write the command ping 10.0.0.2, at the same time, PC number 1 will generate one packet. What is the name of that packet? ICMP packet. What is the name of that packet, guys? ICMP packet. Clear? Understand? Now, in ICMP packet, what will be the content, guys? First, ICMP header. ICMP header. In ICMP header, there are two fields. First, type field and second is code field. If you guys know something about the ICMP, type field will be 8. Why? Because this is the ICMP request, echo request. That's the reason in type field you will see the value 8 and code always be 0. Fine. Now, after ICMP header, there is a which header, guys? At layer number 3, IP header. At layer number 3, which header? IP header. In IP header, source IP will be 10.1. What is the destination IP? 10.2. Now my question is, how PC number 1 know about the destination IP address? No, I am asking how PC number 1 know about the destination IP address, not MAC address. Because you already write the command ping 10.0.0.2 on PC number 1. Fine. So that's the reason PC number 1 already know what is the destination IP address. 10.2. 10.2. So destination IP address is 10.2. Protocol number will be 1 because ICMP use protocol number 1. Fine. So that's the reason protocol number will be 1. Now, after IP header, there is a Ethernet header. Which header, guys? Ethernet header. In Ethernet header, what is the content? Destination MAC, source MAC, then type field. There are multiple fields, but the important is these three: source, destination, and type. What is the source MAC address? 0A. 0A. And what is the type field? In type field, you guys see the value 0x0800. Why? In type field, only two things are there. Either 0x0 800 or either 0x0806. Fine. What do you mean by 800? If 800, it means at IP header or at layer number 3 there is a IP protocol. Fine, or IP header, then value will be 0x0800. And if there is a 806, it means there is a ARP packet. Fine, understand? Now, try to understand PC number 1 don't know what is the destination MAC address of PC number 2. PC number 1 don't know what is the MAC address of PC number 2. So that's the reason what PC number 1 will do. PC number 1 will hold this ICMP packet. What PC number 1 will do? PC number 1 will hold this ICMP packet. Clear? Understand? Why PC number 1? If anyone asks you very simple question, why PC number 1 is holding this ICMP packet here? Because PC number 1 don't know what is the destination MAC address. Now, if PC number 1 don't know what is the destination MAC address, then what PC number 1 will do, guys? Generate the ARP packet. Which packet? Address Resolution Protocol, that is ARP. What is the use of ARP? By the help of ARP, we can find out the destination device MAC address, right? Tell me yes or no. Yes, na?
Yes.
By the help of ARP packet, you can find out destination device MAC address. So now PC number 1, what PC number 1 will do? PC number 1 will generate the ARP packet. This is the ARP packet. There are two types of ARP. ARP request or ARP reply. So this is ARP request. Because PC number 1 is requesting MAC address, that's the reason this is the ARP request. Fine. So in ARP request, what is the content? First is ARP header. ARP header. In ARP header, you will see source IP, source MAC, target IP, and target MAC. In ARP header, there is a keyword target, not destination. Fine. So please remember this one. So what is the source IP? 10.1 because PC number 1 is generating this ARP packet. What is the source MAC? Source MAC is 0A. This is the MAC address of PC number 1, right? Now, what is the target IP? Target IP PC number 1 already know, that is 10.2, right now? Now, what is the target MAC? Please remember, target MAC will be 00000. Why? Because PC number 1 don't know what is the MAC address of PC number 2 right now. Now, after ARP header, there is a Ethernet header. Ethernet header. In Ethernet header, what is the content? First is source MAC. What is the source MAC? Again 0A. Now type field. Tell me now type field. 0x0806. No, now 806 because there is a ARP header, na? I told you, na, in ARP field only there are two value, either 0x0800 or either 0x0806. When 0x0800, when there is a IP header. And when there is a ARP header, then value will be 806. Yes. Got it, na? Everyone. Yes. Yes. I have like this. I have like this. Let me share with you. See, I have like this. Okay. So it will. Yes, definitely. I will share with you guys. Okay. Right now, I'm just explaining everything. So that's the reason I am writing here. Otherwise, I will share the. Otherwise, I will share the PPT with you so you guys can revise it. Fine. Okay. So, so yes, in ARP, this is the ARP header. Fine. Now there is a Ethernet header. In Ethernet header, first content is source MAC, that is 0A, type field 0x0806. Then there is a destination MAC as well. But tell me right now, PC number one don't know what is the destination MAC address. So please remember, ARP request always be broadcast. No, all are F. In Ethernet header, all are F. In ARP header, value will be 0000. Fine. So PC number one will generate this ARP request, and this ARP request will receive on switch interface 0 by 1. 0 by 1. Now what switch will do? What switch will do? Guys, basic function of switch. Yes, the basic function of switch is, first of all, switch will perform the learning task. After learning task, switch will perform the forwarding task. Fine. So what switch will do? First of all, switch will see I am receiving this ARP request on Ethernet or fast Ethernet 0 by 1. 0 by 1. Now, what switch will do? Switch will check what is the source MAC address. What is the source MAC address here? 0A. Because we know switch is layer 2 device. So switch only check layer 2 detail, not layer 3 details. Fine. So switch will check what is the source MAC address, that is 0A, and I am receiving this source MAC address on my fast Ethernet 0 by 1. So what switch will do? Switch will learn this content where? In CAM table. 0 by 1 MAC address is 0A. Fine. Understand, this is the learning task. Clear? Now, after learning, switch will take the forwarding decision. But how? On the basis of destination MAC address. Fine na? Layer 2 destination MAC address. So guys, what is the destination MAC address here? FFFF. So it means switch will broadcast it. You know na, I hope you guys already know switch can unicast the packet, multicast the packet, and broadcast the packet. Tell me yes or no. You guys know na? Unicast, multicast, or broadcast.
Yes,
This is the
yes,
basic thing.
yes.
Switch can perform unicast, multicast, and broadcast. Fine. I hope you guys already know unknown unicast. Otherwise, I will definitely explain you. So, what switch will do? Switch will learn this address 0 by 1 interface, and I'm receiving this on this interface. MAC address is 0A. And after checking destination MAC address, that is FFFF, switch will take the forwarding decision and switch will broadcast this packet towards PC number 2. So finally, PC number 2 will receive which packet, guys? ARP request. ARP request. Now, what PC number 2 will do? Again, PC number 2 will do two things. First, learning, and second, forwarding. PC number 2 also perform two tasks. First is learning, second is forwarding. How PC number 2 will learn? Again, every PC maintain one table. What is the name of that table? Please remember, ARP table. Which table? ARP table. In ARP table, basically PC number 2 learn which thing? Tell me. MAC ID. Okay. Then, yes, in ARP table, very good. PC maintain two things, IP address and MAC address. So PC number 2 check in ARP table, in ARP request packet, PC number 2 will find what is the source MAC address, that is 0A, and what is the IP address of the source MAC address, that is 10.1. So PC number 2 store these information in which table? ARP table. Now, yes, you can say. But in CAM table, there is only difference. In CAM table, you will never see the IP address. Fine. But in ARP table, you will see the IP address, because in CAM table, because switch perform every action on the basis of MAC address table or layer 2 address table. So that's the reason you will never see the IP address. Fine. But in PC ARP table, you will find the IP address along with the MAC address. Or you can say IP in multiple book. Mm-hmm. No, in layer in no in la- yes, in layer 3 switches you will see the IP address. Yes, yes, yes. That is the difference. In some book you will see na in PC that PC maintain ARP table, but how IP MAC mapping. So IP MAC mapping means what? What I'm telling, IP map MAC mapping. So what do you mean by this? Yes, this is the IP address and this is the MAC address of this IP address. Fine. So that is known as IP MAC mapping. Clear? So what PC number 2 will do now? PC number 2 already received this ARP request packet. Now PC number 2 will generate the ARP reply. Which packet, guys? ARP reply. You know, na PC number 1 don't know what is the MAC address of PC number 2. So that's the reason PC number 1 already generate the ARP request. Now PC number 1 is expecting ARP reply. Tell me yes or no. Yes. So PC number 2 will generate the ARP reply. In ARP reply, what is the content, guys? Tell me. First of all, there is a ARP header. Yes or no? Yes. In ARP header, you will see what is source IP. Source IP will be 10.2 now. Source MAC will be 0. B target IP 10.1 and target MAC. Guys, tell me one thing. Now PC number 2 already know na what is the target MAC address. Yes or no? Because PC number 2 already received the ARP request packet, and in ARP request PC number 2 already know 10.1 and MAC address of 10.1 is 0A. So PC number 2 fill target MAC as a 0A. This is the ARP header. Now after ARP header there is a Ethernet header, right now. So what is the destination MAC address? 0A, or source MAC address 0B, and again type field is 0x0806. Fine. So PC number 2 generate this ARP reply. This ARP reply will reach on switch interface 0 by 2. What switch will do? Again, switch will check the source address. What is the source address? 0B. So this switch will make an entry like on 0 by 2 interface. I am receiving MAC address 0B. Fine. This is the learning task. Now what switch will do? Switch will check the destination MAC address. That what is the destination MAC address? 0A. Destination MAC address is 0A. So guys, one more note. ARP request. That is ARP request packet. That is unicast, multicast, or broadcast? Broadcast. ARP reply. Unicast.
Unicast.
So please remember this one, okay? Because this is ARP reply is the unicast packet. So switch receive this packet and switch will check the destination MAC address, that is 0A, and switch will forward. Switch again check the CAM table, and in CAM table switch will find 0 by A MAC address learned on which interface? 0 by 1. So switch will forward this packet through 0 by 1. Understand everyone till now? Uh-huh. Yes, at layer number 2, or you can say in same subnet forwarding, yes, the same process switch will perform. Yes, even in the layer 3 switches. Yeah, basically what I am telling, on the basis of layer 3 address, you can perform the routing. Basically on layer 2 switches, you cannot perform the routing. What I am telling, on layer number 2 switches, you cannot assign the IP address. Fine. But on layer 3 devices, you can. Yes, on the physical port. So now switch will forward. Mhm. The format of CAM table is on layer 2 and layer 3. Yes, yes, you can say it's almost same. Okay. So switch already forward this ARP reply packet, and this ARP reply packet will reach on PC number 1. So tell me now what PC number 1 will do? Yes, PC number 1 already received the reply from PC number 2. Then, guys, I told you na PC number 1 already maintain one table. What is the name of that table? ARP table. So yes, it update the ARP table. What is the update? IP address 10.2 and MAC address is 0B. Now, after that, what PC number 1 will do? PC number 1 just update the ICMP packet 0B here, destination MAC address. Because now PC number 1 already know na what is the destination MAC address. Now, what PC number 1 will do? PC number 1 will forward this ICMP packet towards switch. What switch will do? Switch will again check what is the source MAC address. Source MAC address is 0A. Switch reset its timer, or you can say again learn these things, and switch will check the destination MAC address. Destination MAC address is 0B. Again, switch check its CAM table. What is 0B? 0B is belongs to which interface? 0 by 2. So what switch will do? Switch will forward this packet through 0 by 2. 0 by 2. And finally, this packet will reach on PC number 2. So PC number 2 receive which packet, guys? ICMP request packet. ICMP request packet. Again, what PC number 2 will do? PC number 2 again generate ICMP reply packet. Everything will be same, only source and destination address will change. Fine. PC number 2 will generate the ICMP reply. This ICMP reply again reach on switch. Switch will check what is the destination IP address or destination MAC address. That is 0A, and 0A belongs to 0 by 1, and switch will forward this packet towards PC number 1. And this is the way how switch will perform the packet flow in the same subnet. I hope you guys understand. Anyone who do not understand? Guys, by default time is 300 seconds. This is Yes, this is called aging time. By default, aging time is 300 seconds. If this switch will not receive any packet from PC number 1 till 300 seconds, switch will erase the entry from its CAM table. Erase the entry from its CAM table. I am just telling you one more concept here. Try to understand. Let's suppose this is the switch number 1, this is the PC number 1, this is the PC number 2. Scenario is same. Fine. Let's suppose, yes, our PC maintain which table, guys? ARP table. So in ARP table, 10.2 0B and 10.1 0A. Clear na? Any doubt, anyone? PC number 1, PC number 2 already know these things. And one more thing. In ARP table, PC hold this information for how much time? 4 hours. 4 hour. Fine. Now, and in switch 300 second. Fine. Now let's suppose for any reason PC number 1 is not sharing any packet towards PC number 2. So what after 300 second what will happen? Switch erase all the entry from its CAM table, right? But in PC, yes, but still all the information is present in which table? ARC table. Now suddenly what is happening? PC number 1 wants to communicate with PC number 2 after 300 seconds. After how much second? 300 seconds. PC number 1 generate the ICMP packet. Yes. So see, right now, if PC number 1 wants to connect with PC number 2 after 300 seconds, in this case, PC number 1 do not generate the ARP packet because PC number 1 already have destination MAC address in its ARP table, right? So PC number 1 directly generate which packet? ICMP packet. Fine. What is the source IP address? 10.1 destination IP address, 10.2 source MAC address, 08 destination MAC address, 0B. Clear? This packet will reach on switch. What switch will do? Switch will try to figure out and try to check its cam table, but in cam table, nothing is there. So what switch will do? Switch will broadcast this packet. If there are multiple interface, then switch will broadcast this packet. Why? Yes, broadcast through all the interface except that interface on which this switch receive this packet. Fine. So switch will broadcast this packet, and this type of broadcasting is known as unknown unicast flooding. This type of flooding is known as unknown unicast flooding. If anyone asks you very simple question, what do you mean by unknown unicast flooding? Then tell unknown unicast flooding means if switch do not have entry in its cam table, then switch will broadcast this packet. That is known as unknown unicast flooding. Clear, everyone? Sachin, Sekhar,
Yes, sir.
I
Yes, sir.
hope you guys. I hope you guys understand how packet is forwarding here in same subnet.
Yes.
Okay.
Yes, sir.
Yes. Yes. ARP table erase. Yes. ARP table lost the entry after 4 hours. Yes. Then again, PC number 1 will generate the ARP packet. ARP request. This
Then
is
again,
always broadcast. This
then
is
again
always
switch broadcast.
Yes. This ARP request will reach on the switch. Switch will broadcast it. Fine. Yes. So I hope if you guys have this type of topology, you guys can understand how switch will broadcast it. Clear? If you guys understand
Yes.
previous one, then I hope you guys understand this one as well. Tell me yes, no. This is the exact same scenario. Let's suppose this is the just a minute. Okay. So just tell me one thing. If PC number 1 wants to connect with, let's suppose, PC number 3, what will happen? Anyone? Yes. PC number 1 generate the ARP request. Fine. Then yes. First of all, this generate the ARP table. This ARP packet will reach on switch. What switch will do? Switch will learn the source address. Yes, and
MAC
maintain.
address.
This is the, let's suppose this is the cam table. This is the cam table. So in cam table, this switch will learn all the detail in its cam table, and this switch will broadcast this packet. Fine. Tell me yes or no. Yes, na.
Yes.
Wait a minute. Let me. Yes. Yes, there are two switches. Then no problem. What is the problem? Fine. I don't know what is happening.